So next topic is a matrix as an operator. So matrix operator, and we will talk about linear transformation. So what is a linear operator? What is a linear operator? So if, let's say, O is an operator, then if you operate on A plus B, that will give you OA plus OB. And if you operate KA, K, if an operator satisfies these two conditions, we say that it's a linear operator, where K is a number A and B are it may be a number, function, or vectors. So we have to see matrix as an linear operator. So let us first consider set of equations x is ax plus by and capital Y is cx plus dy. This is a linear system of equations. Where a, b, c, d are some constant. A, B, C, D are some constant. So for each xy, you will get capital XY. Now in matrix notation, we can write this as, it's a column vector xy, and you have a matrix A, B, C, D, and that you should operate on xy. So this can be written in matrix form, where I am taking this as some vector R. Let's say you have a vector R, and this is M R. Component of vector R is capital X and Y. So for given xy, you will get capital XY. In vector notation, you can write it as vector R is M you are operating M on vector R and you are getting a new vector, where component of new vector is this solution. So now you have to see this M matrix M is an operator. This M is an operator. Why? Because if you operate this matrix on any two vectors R1 plus R2, you can write this as, this can be written as MR1 plus MR2 and also if K is some number, you are operating on some matrix R, this can be written as KMR. So that satisfies this condition. So M is a linear operator. ठीक है? M is a linear operator. Now we can visualize this equation in another form. If you can think of xy is a point in some xy plane, and when you are operating on a matrix or operating on a vector, you will get a new vector. So you are getting a new vector. So that is rotating this vector from R to capital R. So in this case, each point of xy plane being moved to another point. Each point of xy plane being moved to another point with origin remaining fixed, or on origin remaining fixed. This transformation is called mapping or transformation of plane into itself. This transformation is called as mapping or transformation of plane into itself. For each xy point, you are getting another points. So it means if you have a vector R that is rotated to some other vector R. So M is like a rotation matrix that will rotate the vector from R to capital R in xy plane.
Small x, y, smaller.
This component is component of vector R is xy. And capital R is capital XY. Yes, small r to capital. Clear? Now, geometrically, R is equal to MR. Can be explained in two ways. So I am first considering case 1. Let's consider case 1. In case 1, we have one set of coordinate axis. This is the origin, and this is vector r. This point is xy, and you have another vector capital R. This point is capital XY. So when we operate matrix M on R, it will rotate the matrix by an vector by an angle theta. So you have one set of coordinate axis. In same plane, if you operate matrix M on R, you will get another vector. So it will rotate the vector by an angle theta. So this type of rotation is called as active transformation. This is called as active transformation, where vector is rotated. In active transformation, vector is rotated. XY plane being fixed, vector is rotated. Vector is rotated. Case 2, now we have two sets of coordinate axes and one vector. This is one set of coordinate axis, and we have another set of coordinate axis, x dash, and this is y dash, that is rotated by an angle theta. And you have one vector. That vector is r is equal to r dash. Where this component is x and this component is y, and component related with x dash y dash axis will be x dash y dash. So you have two sets of coordinate axes and one vector. Component with respect to xy is x and y, and component with respect to, for same vector, if you see component with respect to x dash y dash, that component is, this component is, yes, that will be just, this is y dash and this component is x dash. So in case 1, you have one set of coordinate axis xy, and you will, when you operate on matrix M on vector R, you are getting a new matrix, a new vector. So this type of transformation is called as active transformation when vector is rotated. Here two sets of coordinate axis, one vector. So vector is not changing, axis is rotating, so their component of same vector is changed from xy to x dash y dash. So this transformation is called as passive transformation. Passive transformation. So in case 2, we can write this equation. R is equal to mr dash or R dash is equal to, you can write it as, let's write it as R dash is M R dash. R dash is MR. R dash is MR. So same matrix, matrix M is ABCD. So if you know component with respect to X, Y, how you will write this? So you can write X dash Y dash. This will be ABCD. And this is XY. So if you know component in XY plane, and if you operate this matrix M, you will get component with respect to X dash Y dash system. R dash is equal to MR. Now instead of this capital R, I am taking R dash. So now you have two sets of coordinate axes. Same equation can be visualized in this form also. Here you are getting a new vector, its component, but same matrix, if you are operating on XY, you know the component with respect to XY system. What will be the component with respect to rotated axis? So that you can calculate from same transformation. So one I am calling it as active transformation, and this I am calling as passive transformation. Both you can calculate. Clear? Now we are interested in a special type of transformation, and that is called as orthogonal transformation. What is an orthogonal transformation? Orthogonal transformation, it preserves the length of the vector. It preserves the length of the vector. Length of the, when length of the vector is not changed, means you are rotating from R to capital R, but their length is same, means capital R is small r, their magnitude is same. So, and in this case also, just see this R or R dash, their magnitude is same. So, what condition you will get? You will get X dash square plus Y dash square is X square plus Y square. So, we have to see what will be the matrix M. So, that you will see under this condition, M is an orthogonal matrix. So when M is an orthogonal matrix, this transformation is called as orthogonal transformation, and it preserves the length of the vector. If M is orthogonal matrix, it preserves the length of the vector. So when M is an orthogonal matrix, then you will see this R is equal to, and also R dash is equal to this magnitude I am writing. Length of the vector will not change, and that you can check also. So when you apply this condition from this relation, what will be X dash? So X dash is given by what? X dash is AX plus AX plus BY whole square, and then plus CX plus dy whole square. So if you expand this, what will be component of x square? This is a square plus c square. This is x square. What about y square? This is b square plus d square, plus you will get xy component is 2 times AB plus CD xy, and that will be x square plus y square. So if it preserves the length of the vector, what condition you will get? A square plus C square is 1. B square plus D square is 1. And AB plus CD is 0. AB plus CD is 0. So now just check this condition. What will be M transpose M? So M transpose is given by, this is A, B, C, D. And what will be M matrix? A, B, C, D. And let's multiply it. This is given by A square plus C square. And this will give you AB plus CD. And this will give you AB plus CD. And this is B square plus D square. And this value is 1, this is 0, this is 0, this is 1. So you are getting an identity matrix. So when you consider that transformation preserves the length of the vector, it means matrix must be an orthogonal matrix. Same thing you will get for a unitary matrix. If you have a complex matrix, it also preserves the length of the vector. So for orthogonal matrix, there is another property that it preserves the length of the vector. Now there is another property that you can see. What will be if M is an orthogonal matrix? So M is an orthogonal matrix. So what will be determinant M transpose M? So this value is determinant M transpose determinant M, and this value is 1 because this will be determinant I is 1, and M transpose has same determinant, so that will give you determinant M whole square is equal to 1. So determinant M will be plus minus. So for orthogonal matrix, determinant will be always plus minus, either plus 1 or minus 1. Okay? Now you should remember this point, that if determinant of a matrix is 1, so this corresponds to rotation. So it means M corresponds to rotation. So there will rotation is involved. When what will be determinant of this value? So that is determinant I is 1, and determinant A into B is determinant A into determinant B. Transpose of determinant is same, so that will be square. So determinant M will be plus minus 1. So whenever orthogonal matrix is given, I am talking about 2 cross 2 matrix, and its determinant is 1. So that corresponds to rotation. That will rotate a vector by active transformation I am talking about. That there may be a passive transformation also. So whenever determinant is 1, it involves rotation. And when determinant M is minus 1, then there is a reflection through a line. We will talk about reflection through a line. I am talking about 2 cross 2 matrix. When it is 3 cross 3, then it will be reflection through a plane. In 2 cross 2, there will be a reflection through a line. So let's write the matrix M in case of active rotation. What will be the matrix in case of active rotation? So I am using it. M is an orthogonal matrix and this R is equal to R. So what will be, let's assume this angle is, I am taking this angle to be phi. This angle I am taking to be a phi angle. So what will be small x? That will be given by R cos phi. And what is small y? That will be R sin phi. This angle is phi. So what will be component? X will be R cos phi and y will be R sin phi. And what about capital X? Capital X will be what? Component of this will be capital R cos theta plus phi. So because R is equal to R, so this is written as capital R cos theta plus phi. And that will be same as small r cos theta plus phi. So what will be this value? Cos A cos B minus sin A sin B. So what will be capital X? This is x cos theta and minus y sin theta. This will be capital X. Because r sin theta is replaced, r sin phi is replaced by y. So in terms of theta, this will be x cos theta minus y sin theta. Because M is an orthogonal matrix, so it preserves the length of the vector. Length of the vector is not changing because M is an orthogonal matrix. What will be capital Y? Again capital R sin theta plus phi. So that is a small r sin theta plus phi, and this will be given by capital Y is sin A cos B plus cos A sin B. So r cos phi is what? X sin theta, and this is plus y cos theta. This will be y. Yes or no? So here I am talking about r is equal to r dash is r. So how you will write this transformation? What will be capital XY? Just see. This will be given by cos theta minus sin theta, and this is sin theta cos theta, and this will be XY. From XY, you can write this equation. R is equal to MR, where M is an orthogonal matrix, and this particular matrix is rotating the vector in anti-clockwise direction. Theta is in anti-clockwise direction. Determinant is 1. Cos square theta plus sin square theta is 1. So this matrix is for active transformation. This is for active transformation. So whenever some matrix is given and they will ask you what active transformation it will take, so you have to compare with this matrix. If you compare with this matrix and you will get theta value, and if theta is positive, then you will say there is a rotation in anti-clockwise direction. Positive theta means plus theta means anti-clockwise direction. If you are getting theta negative, it means rotation will be in clockwise direction. So for given matrix, you can check what transformation it will take, whether it will rotate the vector in anti-clockwise direction or clockwise direction. Clear? In same way, can you find matrix M for passive transformation? Let's find for passive transformation. Now we will assume, let's assume this angle I am assuming to be phi. Let's say this angle will be phi. So what will be this angle? This will be phi minus theta. So it means again x will be what? X and y is same because r dash is equal to r here. So x is equal to r cos phi and y is r sin phi. What will be x dash? X dash is r dash cos phi minus theta. Can we write this? Now vector is not changing, but their component with respect to two axes is different. With respect to xy, component is xy. With respect to x dash y dash, component is x dash y dash. So now r dash is equal to r. So this will be given by r times cos A cos B plus sin A sin B. So what will be x dash? X cos theta. This is x cos theta plus y sin theta. This will be x dash. This will be x dash. And what about y dash? Y dash is r dash sin phi minus theta. R dash is small r, so that is r sin A cos B minus cos A sin B. So y dash is given by, this is y, so you will get y cos theta minus x sin theta, or this equation can be written as y is minus sin theta x plus cos theta. So this is y dash. So if xy, you know the component of the vector with respect to xy system, you can find the component with respect to x dash y dash system. So now we can remember this matrix x dash y dash. This will be given by, this is the case of passive transformation. So what will be this matrix? Cos theta sin theta, and this is minus sin theta cos theta, and this component will be xy. In both case, determinant is 1, so they corresponds to rotation. So whenever they will ask you by what angle axis is rotated. If matrix is given, you have to compare with this matrix. And when they will ask you by which angle vector is rotated, so you have to compare with this matrix. And both are giving you rotation in anti-clockwise direction. Please remember here theta is in anti-clockwise direction. Vector is rotated in anti-clockwise direction, this will be the matrix. Axis is rotated in anti-clockwise direction, this will be the matrix. Clear? Means here both vector is rotating in anti-clockwise direction, axis is also rotating in anti-clockwise direction. So you have to compare with these metrics. Theta is positive. For example, let's say in exam they have given you that axis is rotated in clockwise direction by minus 45 degree. What will be the matrix? So here you have to put theta is equal to minus 45. If they have given you that axis is rotated by 45 degree in anti-clockwise direction, then put theta positive here. When it is rotated clockwise, put theta negative. If vector is rotated in clockwise, put theta negative, then you will get the matrix. Clear? So that's why I am specifying here theta is in anti-clockwise direction, so that theta is positive. In clockwise direction, theta will be negative. Okay? So R is equal to MR, that linear system of equation. We have to consider these two cases, active transformation and passive transformation. In one, vector is rotated, here axis is rotated. In both cases, determinant is 1. Whenever determinant of orthogonal matrix is 1, it corresponds to rotation, either active rotation or passive rotation. When determinant is minus 1, there is a reflection through a line. There is a reflection through a line. So you have to remember these points. Clear? ठीक है? क्लियर? इसमें कोई डाउट है तो बताओ. दिस इज वेरी इंपॉर्टेंट, इससे क्वेश्चन आते ही हैं. अभी का जो ट्रेंड है, क्वेश्चन यहीं से आ रहा है. So now we will take some example. So what transformation corresponds to each of the following matrices? First is matrix A is given as, this is 1 by 2 minus 1 under root 3, and here I am talking about passive transformation. Let's assume it's a case of passive transformation. What active transformation? What active transformation corresponds each of the following matrices? So this is first matrix A. So first you have to find determinant of A. Let's check what will be determinant of A. And you should also check that A transpose A is an identity matrix. First you have to see whether it is orthogonal or not. So if you check, it's an orthogonal matrix. I am talking about orthogonal matrices only. You have to use this when matrix is orthogonal. So you can easily check A transpose A is identity. And when you calculate determinant, you have to write, just multiply each element by 1 by 2 and then find the determinant. So you are getting 1. and A transpose A is also identity that you can check. It means this corresponds to rotation. This corresponds to rotation. So what is our matrix? Active rotation. This is given by cos theta minus sin theta and cos theta. This will be the matrix for active rotation. So you have to compare with this matrix. This corresponds to rotation. So what will be cos theta? Cos theta is minus 1 by 2 and sin theta is minus under root 3 by 2. So what will be this value? A? No, minus sin theta is under root 3 and cos theta is minus 1 by 2. This is given up. You are comparing this matrix with your known matrix, rotation matrix. No, this will be minus 1 by 2, no? This matrix is minus 1 by 2 under root 3 by 2 minus 1 by 2. This is your, if you have to find determinant, first you should write in this form. One value is, so this is plus root 3, this is minus. Let's check the determinant. This determinant will be what? 1 by 4 plus 3 by 4. So this value is 1. This is correct. So now what will be theta value? What will be theta? So theta is given by, this is 180 degree plus 60 degree. What will be this value? Cos 180 plus 60, that is minus cos 60. So this is minus cos 60 and that will be minus 1 by 2. So theta positive value will be what? 240 degree. This is the positive theta. It means if you operate this matrix on a vector, it will rotate the vector in anti-clockwise direction by 240 degree. This particular matrix will rotate the vector in anti-clockwise direction by 240 degree. Because this is an active transformation, you have calculated the positive value of theta and we have derived that this particular matrix will rotate the vector in anti-clockwise direction. Theta is 240 degree. So A will rotate the vector in anti-clockwise direction. This will rotate the vector in anti-clockwise direction. Or in another way you can say theta is minus 120 degree. Both are same thing. You are rotating 224 in anti-clockwise or minus 120 clockwise, both are same thing. So when you are taking minus 120, it means this will rotate the vector in a clockwise. So you will get same vector. Clear? So they will give you an orthogonal matrix. You have to check determinant is 1. If it is active rotation, compare with this matrix, you will get angle theta. By what angle vector will be rotated? So in anti-clockwise 240 degree and in clockwise minus 120. If I take one example here, let's take for same matrix, let's say vector R is, if I am taking vector R to be I cap or X cap. Let's operate this matrix on I cap. So what you will get? I am operating matrix A is, this is 1 by 2 minus 1 under root 3 minus root 3 minus 1. So I cap is given by 1 0. what vector you will get here? Just check. I think that will give you 1 by 2 minus 1 minus under root 3, or this vector is given by minus 1 by 2 I cap plus under root 3 j cap. I am taking one example to show you that it will rotate a vector by 240 degree. So you have operated this matrix I cap direction. New vector you are getting minus 1 by 2 I cap plus root 3 j cap. And you can easily find angle between two vectors. Check that angle, that will be 240 degree. If you find the angle between I cap and I cap plus root 3 j cap, that angle will be 240 degree. So that you can verify here also. Is it clear? Now next is,
इन दोनों के बीच में 240 डिग्री.
I have taken, what does it mean? This if you operate matrix A on any vector, it will rotate that vector by 240 degree. I am taking one example. Let's say you are operating this matrix to I cap. So you are getting this vector. So what should be angle between I cap and this vector? That must be 240 degree, because that we have discussed here. For this particular matrix, theta will be 240 degree. Clear? Now you have another matrix B. Let's say this matrix is B is 1, 0, and you have 0, minus 1. So this is an orthogonal matrix. So B transpose B is identity, and determinant of B is what? Minus 1. So this corresponds to reflection. A reflection through a line. Now, what do you mean by reflection through a line? So, if you operate a matrix, any matrix, let's say A, let's take as B. And if it doesn't change sign, if you are operating on a vector and it doesn't change sign, then this will be a reflection line. Why? Because if there is a reflection line, I am assuming this to be a reflection line. And if you have any point on this line, so there will be no change, you will be on the same line. But if you have any vector that is perpendicular to the reflection line, let's say this vector is R dash. So if you operate same matrix on R dash, what you will get? Minus R dash, because then it will change its sign. That is the meaning of reflection through a line. If you are operating along the line of reflection, there will be no change in sign. But if you have some vector perpendicular to the reflection line, it will change sign. So using this concept, we can find the line of reflection. Sometimes they may ask you what will be the line of reflection. So what you have to do, let's operate this 1, 0, 0, minus 1. I am assuming line of reflection is XY. I am assuming this. So satisfy this condition. B R is equal to R. Let's satisfy this condition. Then this will be a reflection, that will give you the reflection line. So what you will get here? This will be X and this will be minus Y. So this is XY and if we, from this you will get x is equal to x minus y is equal to y. So this will give you 2y is equal to 0 or y is equal to 0. If you impose this condition, you are getting y is equal to 0. So what will be reflection line? R, x, y. So this will be y is 0, you are getting x is equal to 0. Or simply, if you write the normalized vector, 1, 0. This will be the reflection line. In this case, I have assumed that BR is equal to R, means I am assuming R is a reflection line. So if you impose this condition, that is giving you y is equal to 0. So R will be xy, when y is 0, x 0, normalized will be 1, 0. So I cap direction or x axis is the direction of reflection. That is the line of reflection. Clear?
Here BR is equal to R and that condition we explain on the.
Let's say determinant is -1. So now you are looking for line of reflection. So if you operate the matrix along the line of reflection, that vector will remain same. It will not change sign. There is no reflection along that line. No. This, I am telling you, if you operate this matrix on R, it will remain same. It will not rotate it. That vector will remain same. So that will give you the line of reflection. What do you mean by reflection along a particular line? Let's say if you are reflecting around this line, so this point will be reflected like this, so this becomes minus r dash. So that's why I'm telling you, if you have any vector perpendicular to the line of reflection, it will change sign. So this r dash is perpendicular to it. So that's why it is changing sign. But if you have any vector along the line of reflection, it will not change sign. So using this, you can identify the line of reflection. You can also check that if you take any vector perpendicular to the line of reflection, it will change sign. So for example, if you have taken I cap, it is not changing sign because that is line of reflection. But if you are taking J cap, that is perpendicular to the line of reflection, you will see if you operate this matrix, it will change its sign. Let's check. And now I am operating B on J cap. 1, 0, 0, -1. Now let's operate it on J cap. This will be perpendicular to the line of reflection. And what you are getting? This is what? 0. And this will give you -1. So this is -0, 1. So this is J cap and you are getting minus J cap. It means what? J cap is perpendicular to the line of reflection. J cap is perpendicular to the line of reflection.
When B is not producing minus R dash, that means it is not an orthogonal matrix, right?
No. I am telling you, first you have to see B is an orthogonal matrix. That you have checked. Now you have checked determinant B is -1. It means there is a reflection involved. Now what will be the line of reflection? Then you have to, using this condition, you can find the line of reflection. This is orthogonal, determinant is -1. If determinant was 1, then we have to see for rotation. But when determinant is -1, we have to see for line of reflection. Clear? So you should remember how you will find the line of reflection. Clear? So we were discussing rotation and reflection. So let's take another example. Matrix is given. So this matrix is another matrix. Let's take it as C matrix. And this is given as 1/2 -1 -√3 minus root 3 and 1. You have to check. Yes, active transformation. That will be given. Yes, that will be given. So, what will be C transpose C? Check. First check C transpose C. So, I think that will be a identity matrix. You can easily verify by multiplying C transpose and C. And what will be determinant of C? The determinant of C should just multiply. So, you will get minus 1 by 4 and then minus of 3 by 4. So, this value is minus 1.
1 by 2 need not to multiply. 1 by 2 need not to multiply.
Yes, you have to multiply. First, this matrix you have to write as minus 1 by 2 minus under root 3 by 2 minus root 3 by 2 1 by 2. Now you have to find its determinant. So this determinant C is minus 1. So this corresponds to reflection through a line. I am talking about 2 cross 2 matrix. So this is reflection through a line. This corresponds to a reflection through a line. So how to check what will be reflection through a line? If you operate this matrix on some vector R and if it doesn't change sign, so then R will be the reflection line. So to get the reflection line, we will use this condition. So let's operate this matrix. This is 1 by 2 minus 1 minus root 3 minus root 3 and 1, and I am taking this to be xy, component is xy and this is same as xy. So what relation you will get? Multiply row by column. So this will be minus x by 2 minus under root 3y by 2 and that will be x. So this will give you minus x minus root 3y is equal to 2x, or this will give you what? 2x, 3x is equal to minus root 3y. So what will be y? Minus under root 3x. Y will be minus under root 3x. So it means this reflection line R will be given by, this will be x and this is minus root 3x. So this is a, but we have to write its normalized unit vector. So how to normalize it? So this length, or we have to see length or norm of a vector. Length or norm of a vector. So in general, if you have, let's say, any vector A, I am taking the definition, if you have any vector A and I am taking it as a column vector. So this will be given by A, if A is real, so A transpose A. This defines the length or norm of a vector. And if this is 1, so you will get the normalized eigenvector. For a unit vector, this length or norm should be 1. This is when A is real. If A is real. If A is complex, in that case, norm is given by what? A complex conjugate transpose A. This should be 1. So whenever you have to normalize the vector, we will take length or norm of a vector is 1. So how to normalize it? Just normalize this. So we will write it. This is R transpose will be x minus root 3x, and this will be column x minus root 3x. This should be 1. So this will give you x square plus 3x square is equal to 1, or this x will be 1 by 2. 4x square, so x will be 1 by 2. You can also express x in terms of y. Yes, that will not change the rate. Yes, direction will be same. Same direction you will get. So now reflection line is given by R, and R is 1 by 2. This is 1 minus under root 3. And what will be the vector? Vector will be 1 by 2 I cap minus under root 3 j cap. This will be the reflection line. So if you operate matrix C along this line, it will not change the sign. So that is the line of reflection. If you take any vector perpendicular to the reflection line, what will happen? It will change the sign. Let's check. So let R dash is a vector perpendicular to this vector. So what perpendicular vector you can take? Can I take it as root 3 I cap plus j cap? If you take dot product, so this will give you what? Root 3 minus root 3, so that will be 0. This R dash dot R is 0. It means this vector is perpendicular to the reflection line. So if you operate matrix C, you can easily check. If you operate C on R dash, what you will get? This will give you minus R dash. You can easily verify this, because R dash is perpendicular to R. So if R is the reflection line, and if you operate a matrix C, any line perpendicular to the reflection line, then it will change sign. So this you can easily verify. I am taking one example. This particular vector, just operate this, you will get CR dash is minus R dash. So matrix C is given, and you have to see which what type of transformation this matrix corresponds. So this corresponds to reflection through a line. So let's check this. C is what? 1 by 2 minus 1 minus root 3, and this is minus root 3 1, and this vector R is what? 1 by 2 under root 3 1. So if you operate this, what you will get? This is row by column. So what will be this matrix? This will be row by column. So this is minus root 3. This will be minus root 3 by 2 and minus root 3 by 2. So that is just multiply this. So this will be minus under root 3 by 2 row by column, and this will be minus of root 3 by, and what will be this value? Minus 3 by 2. This is minus of 3 by 2, and this is 1 by 2 plus 1 by 2. So what will be this vector? This is 1 by 2, and this will give you minus root 3, and this is minus 1. Just see. So this value is what? Minus of r dash, minus of r dash. So this is simply minus of r dash. So if you operate matrix C along vector r dash, which is perpendicular to the reflection line, it will change sign. Clear? So any doubt up to this point? ठीक है? चलो. Now we will see rotation and reflection in 3 dimensions. Rotation and reflection in 3 dimensions. Rotation and reflection in 3 dimensions. So let's consider a matrix A. We have a matrix A, that is, this is cos theta minus sin theta. This is sin theta cos theta. This will be 0, 0, 0, 0, 1. This is the matrix. Active transformation. We will verify it. We will check it. So it's an orthogonal matrix. You have to check A transpose A is identity matrix. That you have to verify. First you have to check this is an orthogonal matrix, and if you find determinant of A, what will be determinant of A? So just see, this will give you again plus 1, because if you want to expand about this line, so this is with plus, because this is plus minus plus minus plus. So delete this row. So cos square theta plus sin square theta, determinant A is 1. So again, when determinant is 1, that corresponds to rotation. That corresponds to rotation. So determinant 1, this corresponds to rotation. Now you have to see what will be the rotation axis. In this case, we have to identify rotation axis. So again, you have to use this condition. If you operate A on some vector R, if determinant is 1 and you are getting this condition, then R is the rotation axis. R is a rotation axis. There will be rotation about, this is the rotation axis. Now, if you verify, I'm telling you how you will verify that what will, when you have a 3x3 matrix, determinant is 1, so there will be rotation. So what will be the rotation axis? This condition you have to use. That will tell you what will be the rotation axis. If you operate a vector, if you operate this matrix on some vector, so there will be rotation of a vector about this axis. This is the rotation axis. Yes, that is not rotating. That's why it is R. But that is for determinant is -1. If determinant is -1 and you are using AR is equal to, you are getting AR is equal to R, then you will get the reflection line. And that is also the rotation axis. Same condition you have to use. For rotation axis, what will be the rotation axis? You have to use this condition. AR is equal to R. R is the rotation axis. If you have any vector that will be rotated about this particular axis, first thing you have to find what will be the rotation axis. So that you will verify from this condition. So for example here, zero, this is sine theta, cos theta, cos theta 0, 0, 0, 1. So let's operate this on z axis. So this is 0, 0, 1. What you are getting? You will get 0, 0. So it means this corresponds to a rotation of a vector, about z axis through angle theta. This is the standard form. So again, from the given matrix, you have to compare with this, what will be cos theta and sin theta, and then you will get angle theta. Okay? This will be, this is, I am telling you, I am verifying that z axis is the rotation axis. So this is z axis. You are operating matrix on k cap. You are operating matrix A on k cap and you are getting k cap. It means k cap is the rotation axis, z cap is the rotation axis. Okay? There is another matrix B. There is another matrix B, and this is again cos theta minus sin theta, cos theta, and this is 0, 0, 0, 0, minus 1. Now this will be the matrix. You can again check that B transpose B is an identity. So B is an orthogonal matrix. B is an orthogonal matrix. And what will be determinant B? Determinant B is minus of 1. So in this case, there is a reflection, but there may be rotation also. So this corresponds to rotation and or reflection. Both possibilities there or only reflection is there. So in general, there is a rotation and or reflection about rotation and reflection. So this corresponds to rotation and or reflection. So in this particular example, rotation is about Z axis and reflection through XY plane. Now you have to find plane of reflection. So again, if you have to check, in this case, we will check this condition. AR is equal to minus R. AR is equal to minus R. So here R is the rotation axis. R is rotation axis. If there is rotation, rotation will be about this particular axis. This is rotation axis. And what will be reflection plane? Reflection plane will be perpendicular to R. Reflection plane will be perpendicular to R. So, and reflection plane is perpendicular to R. Reflection plane is perpendicular to R. So here rotation is about Z axis. You can verify in this particular example. B K cap, you will get this is minus K cap. For given case, this I am talking about in general. If determinant B is -1, how to check? So there will be rotation or reflection, and in this case rotation is about Z axis and reflection, that is reflection through XY plane. Okay? So because if you operate this on K cap, you are getting minus K cap. So if there is rotation, rotation will be about Z axis, and Z axis is the perpendicular to the reflection plane. In this case, because B K cap is minus K cap, so this Z axis is perpendicular to the reflection plane. So what will be the reflection plane? XY plane is the reflection plane. So both information you will get from this relation. Rotation axis and what will be reflection plane? Reflection plane will be perpendicular to this vector. For example, here rotation axis is K cap and reflection plane is perpendicular to K cap. So that will be XY plane. Clear? This is not A, this is B. This matrix is, I am talking about any matrix, B type of matrix whose determinant is -1. I am talking about matrix whose determinant is -1.
Using this case, determinant -1.
Determinant -1.
Determinant बनाया तो हम लोग पहले वाले.
Yes, you have two possibilities. Determinant is 1 or determinant. If you have orthogonal matrix, determinant may be 1 or -1. So I am discussing both cases. One case is this, where you have to find rotation axis, and then you will check what will be the angle through which it is rotated. If determinant is -1, so there is possibility of rotation and as well as reflection. So rotation axis you will get from this, R will be the rotation axis, but what will be the reflection plane? Perpendicular to R. So for the given matrix, rotation axis is Z axis and reflection through a XY plane. Because if you operate B on K cap, that is changing sign. So Z axis is the rotation axis and perpendicular to Z will be reflection plane. So that is XY plane. Clear? Okay? So you have to remember these two cases. Determinant is 1 and determinant is -1. So take one example. I am giving you a matrix. Let's say this is matrix F. I am taking some matrix F, and this is 0, 0, 1. This is 0, 1, 0, minus 1, 0, 0. Let's say this matrix is given. What transformation corresponds this particular matrix? So first we have to check orthogonality. This is 0, 0, 1, 0, 1, 0 minus. Check for orthogonality. I think you will get F transpose F is identity matrix. First you have to check that matrix is an orthogonal matrix. Then you have to check what will be determinant of F. Determinant of F is 1. So if you expand about this, that will give you 1. So this corresponds to rotation. This corresponds to rotation. So what will be a rotation axis? Yes, let's solve this equation. Fr is equal to R. So try to solve it. 0, 0, 1, 0, 1, 0, minus 1, 0, 0. And this is, in general, I am taking x, y, z. Let's use the general condition. X, y, z. So, and if you compare with this, so this will give you what? Z is equal to x. This will give you y is equal to y. And this will give you minus this will give you z is equal to x, and this is minus x is equal to z. So this condition will satisfy only if both x is 0 and z is equal to 0. Because z is equal to x and z is equal to minus x. So only possibility is both x is 0 and z is equal to 0. So what will be the rotation axis? So this implies r cap will be 0, and if you normalize it also, y will be 1. So 0, y 0. Let's normalize it. 0, 1, 0. This is the rotation axis. This will be the rotation. Y axis is the rotation axis. Y axis is rotation axis. Yes. Minus x is equal to z. This is third one now. So minus x is equal to z. So this will be rotation axis. So let's see if I take this as I cap, this as j cap, this will be k cap. Clear? So in this case, z cap is this is the rotation axis. So if you operate F matrix on I cap, let's operate F on I cap. What will be this? F on I cap. What you will get? If you operate this on I cap is 1, 0, 0. So what you will get? J cap, but I am operating on I cap. You have to see how this vector will rotate about z axis. Rotation axis is z axis, but y axis. Rotation axis is y axis. Now I have taken one vector I cap, and you have to see if you operate this matrix on I cap about J cap, how it will rotate? I cap is one vector, X cap, any vector I have taken, just to show you. You told me, na, you are not able to visualize it. Now you can visualize it. What does it mean? So I am operating matrix F on I cap. So what will happen? Just see. So if you operate 1 0 0, so this will be 0 0. So you will get minus of K cap. Yes or no? Just put here 1 0 0. So you will get minus K cap. So it means what? If this is the rotation axis, this is I cap. So I cap becomes minus K cap. So about Z axis, about J axis or Y axis, this I cap is rotated by what angle? 90 degree. So there is a rotation of a vector by an angle of 90 degree about Y axis. Because I cap is minus K cap and rotation axis is Y axis. So about Y axis there is rotation of 90 degree. So about Y axis theta will be 90 degree. So this particular matrix will rotate any vector about Y axis by an angle of 90 degree. Clear? If you operate on K cap, let's say, just check. If you operate on K cap, same matrix, you are operating on K cap. This will again rotate by 90 degree. Check 0 0 1. So you will get, I think this will be I cap. Just check it. So about Y axis, this will be again rotated by 90 degree. K cap means 0 0 1. So just operate 0 0 1, you will get 1 0 0. Check it. So in question they will give you this matrix and they will ask you what type of transformation this matrix will give you. So because it's an orthogonal matrix, determinant is 1, so this corresponds to rotation. Now you have calculated the rotation axis and you can check what will be the angle of rotation. Sometimes if you have a standard matrix like A and B, you can directly compare for theta. You will get cos theta minus sin theta. But this matrix you can't compare with your A and B. Just see. This, if matrix is given in a standard form, like this particular form, you can directly check for theta value, whether this or this. But otherwise, you have to check it. So this will be clear. So this is one example in when you have a 3 cross 3 matrix. Theta, you have to check it from just by taking example, you have to verify. You have identified the rotation axis. Take some simple case. I cap is rotating in my cap, minus K cap. So there is a rotation by 90 degree that you can check. F I cap minus K cap. If this is the rotation axis, what will be the angle of rotation of vector? 90 degree. If you are operating on K cap about Y axis, it is I cap. So again rotated by 90 degree. So this corresponds to rotation about Y axis by an angle of 90 degree. ठीक है? Take another example. You have a G matrix. G matrix is 0, 0, 1, 0, minus 1 and 0, 1, 0, 0. This is the matrix. 0, 0, 1, 0, minus 1, 0, 1, 0, 0. Again, you have to check what type of transformation this matrix will give. So you have to first check that it's an orthogonal matrix. G transpose is G. In each case, you have to check. And then you have to see what will be determinant of this matrix. Determinant J is 1. So this corresponds to rotation. So what will be rotation axis? Again, you have to check for GR is equal to R. Let's solve this. 0, 0, 1, 0, minus 1, 0, 1, 0, 0, X, Y, Z, and this will be again X, Y, Z. So this will give you what? Z is equal to X, minus Y is equal to Y, X is equal to Z, X is equal to Z. So this will give you Y is equal to 0. So R vector is given by what? Let's say X, 0, X. And if you normalize it, Y is 0, Z is equal to X. And if you normalize it, 2x square is 1. So X will be 1 by root 2. So this is 1, 0, 1. This will be the rotation axis, or this will be given by one vector is 1 by root 2 I cap plus k cap. This is the rotation axis. I cap plus k cap is the rotation axis. Rotation axis. Okay. If you want to normalize a vector, its norm should be 1. So norm means you have to take R transpose R. This should be 1. So R transpose is X 0 X, and this is X 0 X. This will be 1. So this will give you X square plus 0 plus X square is 1. 2x square is 1. So X will be 1 by root 2. X will be 1 by root 2. So if a vector is given, you can normalize so that its mod value is 1. Otherwise, sometimes they may give you I cap plus k cap, that is the rotation axis. This will only give you unit vector in that direction. If normalize the vector, you will get unit vector in that direction. Okay? So this is the axis of rotation. Now you can't visualize by what angle it will be rotated. You can't compare it with your A or B matrix about Z axis. So in that case, there are some trick that you have to remember. So here, let's multiply G matrix. What is G square? G into G. Let's check for G into G. Check it. So if you multiply 0, 0, 1, 0 minus 1, 0, 1, 0, 0 with same matrix 0, 0, 1, 0 minus 1, 0, 0, 0. So here this will give you row by column. So this will give you 1. This will give you 0. This will give you 0. This is 0. And if you this will be 1, 0, 0, 0, 1. You are getting an identity matrix. So whenever you have this type of situation, in that case, G square corresponds to 360-degree rotation. So G corresponds to 180-degree rotation about the rotation axis. Identity. If G cube is identity, if in some cases, let's say if some other matrix, if G cube is identity, then G corresponds to 120-degree rotation. G cube 360, so G will be 120. Here because it is G square, so G corresponds to 180-degree rotation. So you have to remember this method also. Because you can't visualize, there is no way to calculate. So that method is, you have to check for G square, G cube, and then you will get the angle of rotation. And rotation axis you can easily check. Just to normalize it. It's a normalized unit vector. You want to write I cap, K cap, that is also same direction. Direction will not change. Only I am writing the unit vector. I am writing it unit vector. Unit vector in a particular direction. I cap plus K cap is the same direction as 1 by root 2 I cap plus K cap. Only thing is, this is the unit vector. I am writing unit vector. So what is the problem? I am writing unit vector. Direction is not changing. Only thing is, I have normalized this unit vector in that direction. ठीक है? ये clear है? So let's take another matrix. I am taking it as matrix K. Because different matrix corresponds to different transformation. That's why I am taking different symbol A, B, C or F, G, H, K. So this K is, I am taking it as 0, minus 1, 0. This is minus 1, 0, 0, 0, 0, 1. If this is the matrix. This is the matrix. So you have to see this K transpose K is identity matrix. And what will be determinant K? Determinant K is minus 1. Determinant K is minus 1. So this corresponds to rotation or reflection. Rotation and or reflection. And or reflection. So let's check for KR is equal to minus R. Can you find R? Let's check for KR is equal to minus R. So K vector is, this is 0, minus 1, 0, then minus 1, 0, 0, X, Y, Z. This is minus X, Y, and so what you will get here is row by column. So minus Y is minus X. Then second row this column. So this will be what? Minus x is equal to minus y. And what about z? Yes, z is equal to minus z. So this will give you 2z is 0 or z is equal to 0. Z is 0 here. So what will be r vector? R is, so y is equal to x. So this is x, 0. And if you normalize it, 1 by root 2, 1 by root 2, 1, 1, 0. In vector notation, you will get 1 by root 2 I cap plus. So if there is rotation, rotation axis will be this axis. Okay? But here we have to focus on what will be the reflection plane. Yes. So reflection plane, because determinant is minus 1, now you have to find the reflection plane. So let any vector r dash or r1, that is x cap plus y cap, any r1 in reflection plane. I have assumed any vector r1, this is any vector r1 in reflection plane, and this r is perpendicular to the reflection plane. R1 is any vector in the reflection plane. So r dot r1, this must be 0, because r1 is in the reflection plane and this r is perpendicular to the reflection plane. So if you take dot product, what you will get? 1 by root 2 common. So this will give you, this is x cap or I cap. You can take it as I cap or j cap also. Let's write in same form. Instead of this, I am writing it as x I cap plus y j cap. So if you, this will be x plus y is equal to 0, and this will give you x y plus it. So this is the reflection plane. This is the equation of reflection plane. This is the equation of reflection plane. So you can identify what will be the reflection plane.